Hello friends, welcome back. Today we're going to be thinking about higher order functions. And so to start off, we just completed the mutability section, and now we're going to look to the tests. I'm going to grab this file name and maybe a little bit of the path, and then just come over to Atom, press Command P, and that'll get me the file. You could also do it by pressing Command / and get your higher order function file. Or you could just look into a Finder window and open it that way. Okay, cool. So var underscore, and it says here, and it's commented out, it says globals. This section uses a functional extension known as underscore.js. So they show the documentation here. Underscore is a utility belt library for JavaScript that provides a lot of functional programming support that you would expect in prototype.js or without extending the built-in JavaScript objects. It's the tie to go along with jQuery's tux. So just think about it as it's a handful of tools that are kind of added in. So when you have this var underscore, you're setting the underscore, and that has a bunch of these tools, and we'll go through them in detail. So here it describes about higher order functions, and what it's saying is you should use filter to return an array of items that meet a criteria. Okay, so here they're setting up the numbers. And so now it says for the next one, we're setting a variable called odd. Now, so we're going to use the underscore tool, and then we're going to pass in numbers, and then we're going to say filter. So we're going to run the filter method on the numbers. And then we're setting the element that we move through. So if it's, for the example, it's here. On the first pass through, x will be equal to 1. On the second pass through, x will be equal to 2. And on the third pass word, x will be equal to 3. And it's going to return true. Yeah, true. So this is going to be evaluated to false or true. So on the first one, 1 modulo 2 is not equal to 0. Well, 1 modulo 2 is 1, right? So this is going to return, it's going to return the 1 into the function. Then 2 is going to come through. X will be equal to 2. 2 modulo 2 is 0. Because 0 is not equal to 0, because 0 is equal to 0, therefore this is not true, so it won't return, so 2 won't be in here. And so when what will we expect odd to be? It will be this guy. It'll be 1, it'll be an array, and it'll return 1 to 3 here. The length, what is the length of 3? Of 1 to 3? Yeah, 1 to 3 dot length. 2. The length is 2. The numbers dot length. Well, the numbers dot length is going to be equal to 1, 2, 3 dot length. So you know what that's probably 3, right? Cool. So we just put that in there, and we're good to go. So yeah, these can be a little bit tricky at first. So when x 1 modulo 2. That's 1, right? And so 1 is not equal to 0. That's true, correct? Does it make a difference? Oops. So yeah, 1 is not equal to 2. So because that's true, it's returning the value, and it says that that's true. But then once you get on the next one, x becomes equal to 2. 2 modulo 2 is equal to 0. And then 0 is, 2 modulo 2. Yeah. 0 is not equal to 0. Well, that's false, and so therefore 2 doesn't return. And then with the 3, it does the same thing as 1. Okay, cool. Let's move on. It should use map to transform each element. Okay, so filter, what it did was it returns each element that renders out to true or false. Map is going to move through and change everything. So here we've got our numbers of 1, 2, 3. Our numbers plus 1, so we're using the underscore method. We're passing in the numbers. We're mapping across each one. So on the first pass through, x is equal to 1. Return 1 plus 1. So this is going to return. It's going to return, map returns an array, and so it's going to be 1 plus 1. So that's going to be 2, right? And then on the second one, 2 is going to be equal to x. 2 plus 1 is equal to 3. And then then it returns that. And then on the last one, 3 is equal to x. And so 3 plus 1 is equal to 4. So you're going to have 4 like this. Numbers plus 1. Yeah. I think that's right. Then the numbers to equal Fill me in. Numbers. Oh, I think the point is that, does map transforms to each element? I think that the map stays the same, but I'm not sure. So let's save this and then refresh the page over here. And we'll scroll down to the bottom, and it shows that our most recent one is in higher order functions on line 32. And 32 is down here. So yes, that's correct. The underscore does not, the map doesn't mutate the original array. It just returns an array that's complete, that has been mapped on. Cool. So let's move on. It should use reduce to update the same result of each iteration. So numbers 1, 2, 3, and then we have a reduction. So we're reducing it. We take the underscore and we pass in the numbers, and we say reduce, and we pass in the memo. Okay, so this is the result from the last call, and then this is the current result. So x is on the current result is 1. And we don't have anything, so memo is 0. And we're saying memo plus x. So 0 plus 1 is 1. And so that's our reduction is going to be 1. And then now our memo is 1. And so we're going to say 1. And then x becomes equal to 2. So 1 plus 2 is 3. Oops. And then 3 becomes our new memo. And then our new x is number 3. So that's going to be 6, right? And so that is how that one works, I think. So, and then we have our numbers here to equal, well, again, this is just trying, I think it's the point here is just to show you that the original array is not mutated. It just stays the way that it is. So now we can, now that I pressed Command S to save my file over here, and when we come back over here, 32 was failing last time. So if I refresh the page and scroll down, we see 32 still fails. So expected 6 to be true. Okay, so I got it wrong. So here's the way that this works. Is it wants to, I guess the reduce function just passes in the last element, and it's not an array. So I was just not familiar with that. And I still think that this is going to be correct. So let's save over here. So then I guess what it does is the reduction just means that it adds them all up. So that's cool. It was still useful to see the way you walk through that. So let's refresh the page over here and scroll to the bottom. And here we go. Okay, line JS 45. So now our new failing test is this guy right here. And so therefore, we're going to be working on this block. So here we have the numbers again. Then we have a message, var is even. So function, if the item, so we're passing in the function with an item. Okay, yeah, so we're doing callback functions here. The message plus equals item modulo 2 is equal to 0. Okay, so the underscore number, so we're passing in the numbers, and for each, we're saying is even. So on the first one, the item becomes 1. And so the message is an empty string. Here, and we'll just do it here. The message at first is an empty string. So then it's plus equals, so the empty string message plus equal to the first item, which is the first number. So in this example, it's going to be 1 modulo 2. And we're going to say if that's triple equals to 0. Okay, we can't do it that way. But anyways, okay, so it's false, right? So the message becomes false. What happens if you throw a Boolean in there like that? Plus equals false. Invalid left-hand side assignment. Message plus equals false. I think it would be as false. Okay, so I'm thinking what's going to happen is it's going to say for each. It's doing this for each element, and then we want to see what the message is going to be like, and the message is getting iterated on. And so it's just asking if it's even. So I'm thinking that it's going to be false. And then on the second one, true, because instead of at first it'll be false, it'll render out to false, and then it'll say plus true, and then it's going to do it again, and it's just going to say false. And the reason that it's going to say false is because 3 is not even, and so false, true, false. And the numbers, what happens with the numbers? Again, I don't think that the array will be mutated by this process. So let's save that and then come over here and refresh the page. And so I hope that that makes sense. What we're doing is for each of the items, we're running through this process in which we're adding characters onto the message thing. Okay, scroll down. Line 55. Okay, looks like we got that one because 46 was true. Okay, here's 55. It should use all to test whether all items pass conditions. So here, only even, 2, 4, 6, mixed bags, 2, 4, 5, 6. So this one has an odd number in it. Here we set a function to say is even, x. So let's say x is 2. 2 modulo 2 is equal to 0. So this returns true, whereas with 5 it wouldn't be true. So here we're using our underscore library again, and we're saying passing in only the even dot all is even. Okay, so it's going to go through, and this is going to say true, true, true. And so that's going to be true. All is even. And then with this one is even the mixed bag. Well, the mixed bag is going to come up on 5, and that's not going to be even. 5 modulo 2 is 1. This renders out to 1. 1 is equal to 0, so we'll return false, and this is going to stop. So this will be false. Cool, let's save that and then refresh over here. We were on line 55. It looks like now we're on line 65. Cool. So 65 is down here. So it should use any to test if any item passes the condition. So, wow, okay, cool. So this is exactly the same as above, except for now they're saying any. So any to be even, mixed bag any to be false. Yeah, okay, so here what's going to happen, because any, to test if any pass the conditions, what happens when it hits 2? That's going to render out to true, and therefore it's going to say this is true and this is true. Now if you just had a bunch of falses, then that would work differently. And I can't really do this in the REPL because I don't have underscore JS exactly in here, I think. Oh, I do. Okay, cool. So only evens like that. We could go underscore dot, no, only evens. And then we go dot any, and then we just pass in the function, and so we could go function x return x modulo 2 is equal to 0. X is not defined. Okay. I need to make this a lowercase x. Somehow that got an extra case s. Okay, so yeah, it's turning into true. But what happens if we were to go only, instead of only even, we passed in 1, 3, 5, 7, and 9. So all odd numbers. This should be false, right? What if we made, this is the thing that makes any work the way that it does, is if this is 10, we're going to see, or even if it's 190, we're going to see that it renders out to true because 190 is an even number. So yeah, true, true, because both of these have even numbers in them. Here, use range to generate an array. So underscore dot range. I wonder what that does. Underscore dot range. Underscore dot range 3. Oh wow. Okay, cool. If we go 1 to 4. Okay, and the reason that the underscore is working right now is because it's loaded into this file when we update it. That's why it's rendering in the console. So if you're rendering it in a console that's not in this in the JavaScript Koans, it's not going to work. Oh, that's cool. 1 to 4. So you can set the range, and then if we go range is 0, -4, -1. 0, -4, -1. We get 0 to -1, -2, and -3. What does the -4 do? It should generate an array. 0, 4, 1. I wonder what happens if we did like 1. Then it just does 1. Weird. Yeah, I don't know why that is. That's strange. Okay, cool. If you were really interested in understanding how this works, you can always check out the documentation of the project. But I think it's just kind of it's good to practice understanding this knowledge. Cool, so let's save this, Command S, and then I'm going to refresh over here. We'll scroll down to the bottom. Looks like line 76 is our new problem. So if we look over here, here's 76. That's good. That means that we're passing all these tests. This should use to flatten to make nested arrays easy to work with. Oh, okay, cool. So here, I mean, really what we could do is just take this bit of code here and run it in the console to see what it is. And so what I think it's going to be is just an array of 1, 2, 3, 4. Yeah, so it's just 1, 2, 3, 4. So that's what flatten does. It moves through. It's going to take both of these and put them into a new array and then push out the other one. So this is going to be 1, 2, 3, 4. And then, cool, we could refresh the page here so that we can see that the line 86 is going to be our problem. Here it is on line 86. So we expect, oh, here's the answer, but I'm not going to look at that. We should use chain ... value to use multiple higher order functions. Okay, so what they're saying is we're chaining multiple things. So here they've got chain. Oh wow, okay, so you have to use chain. Usually you can just do that. So chain, I guess, just means that it's going to implement all of them. So 0, 1, 2, first off it's going to flatten them. So it's going to make this into an array that is just 0, 1, 2. And then it's going to map across, and it's going to add 1 to each number. So it's going to be 1, 2, 3, and then reduce. Okay, the sum and x. 1, 3. Interesting. And then it's going to give us a value. Okay, well, let's just take it one at a time. I actually don't really know. Yeah, let's do it like this. We can go underscore 0, 1, 2, no, underscore, and then, so this, I'm just going to copy it in here, and then we've got 2. So initially what happens is we have that, and if we go dot flatten, we're going to get 0, 1, 2. And then if we go the flatten, I think we need to put chain in here. Dot flatten dot map, and here we'll add a function of x and return x plus 1. Looks like we have another array, and the wrapped is the 1, 2, 3, and it's still a chain. So this is some of the interesting underscore logic. And then what we want to do is reduce. And then we have this wrapped one. It's wrapped is true. It's a chained off. Wow, look at all the values that are in there. So that's all underscore stuff that's providing you with a bunch of tools. And then, so yeah, if we ran this all, I think the dot value actually just gets it so that you return a number. So wow, yeah, expected 6 is the answer. So that's what happens. So I think it goes in. First off, we flatten the array, then we map across it, we add it, so it becomes 1, 2, 3, and then we reduce it. 1, 2, 3 probably just adds them all together. So 1 and 2 is 3, and then 3 and 3 is 6, and then we just generate a value because the initial one is different. And so now if we save that and we refresh this page, we scroll down to the bottom, it looks good. We are now in about inheritance, which is in another folder. So that's this one. I hope you guys understood the higher order functions. So yeah, this is useful stuff for sure. And whether or not you use the underscore library when you're doing most of your JavaScript stuff, you can still write out these functions, and it's useful to understand. So hope you guys enjoyed this one, and we'll see you in the next video.